spent the whole summer learning Matlab?
Yeah, raise your hand if you learned Matlab. Clear out you. Okay. Raise your hand if you learned Python. Okay. Right. So, the goal of this presentation is that the Matlab hands and the Python hands can work together and kind of understand what each other's codes are, or how to explain code to each other. What you will see is that a lot of the syntax looks almost exactly the same. So hopefully should be easy puzzle. So we'll go through all the basic syntax, and then we'll have a lot of Q&A for specific things you want to discuss. The notes are all online on GitHub. Under 35 EAS 213 has all that. It also has all the course material that the high school is learning. This is the Jupyter Lab programming environment. The reason I'm using it is it supports what are called kernels, so I can run Matlab in it and Python in it and R in it for the people who can actually do that. But so I'm using Octave, so there's going to be slight differences, and I'll show you where I can't show you the Matlab because Octave doesn't support it yet. Okay, and Octave is an open source Matlab clone. Okay, and like stop me and ask all the questions for things you don't got. So the first thing is we want the like generic print to screen function in Matlab is display. Right, so if I display, it spits out that. In Python, it's print hello world. Print hello world. If we want a comment in Matlab, your comment is with a parentheses. In Matlab, also a long comment is actually this, but that's going to create errors here. So that's how we do a long comment in Matlab. I think only the newest versions. And in Python, your comments are a hash for small comments, three quotes underneath the long comments. For variables, it works the same with both. The biggest thing that starts happening in Python is in Matlab, all the mathematical functions are built in. They're built into plain Matlab. So here we can have the Bestly function, and we'll just print Bestly, and it'll give us that. So in Matlab, we get the Bestly function, and it's just generically built in. And it'll print stuff out. The point of the semicolons, they're not required in Matlab. What they do is they suppress the printing. So if I don't have a semicolon, it does this. It just prints each individual space. Python, you don't print a screen. You have to explicitly print a screen using prints here, and it doesn't tell you which variable it's printing. So in Matlab, it'll tell you x equals a equals when you print. In Python, you just have to keep track of it. The biggest difference though with Matlab and Python is this piece, that in Python, because Python is technically a general purpose language, we don't have this stuff baked in. What we do instead is we have to import special numerical computing libraries in Python to do the same stuff Matlab just has baked in. So we import the numpy as P, SNP is the typical convention, but numpy is a numerical Python library. So all your basic matrix mathematics for Matlab are in the numpy library. And we, for the special functions like the Bestly function and other scientific computing functions, usually your signal processing stuff, is in SciPy. So here from SciPy.special, we're going to import the IV function, which is the equivalent of the Matlab Bessel function. This one, Bessel. again, any questions so far? If you're going from one to the other? So basically, for now, it looks the same. Where you start seeing differences a little bit is the string formatting. In Matlab, we use old C style. So the underlying string formatting is the same in Matlab and Python because they're both based on C styles. They're both based on C string formatting. So your codes are all the same. The .fs, the .i's, the .b's. String formatting, if you don't know, is how to make your stuff print pretty. So in Python, our string formatting goes in brackets. And here it's that this star means unpack. So we're going to unpack that A. And in Matlab, we don't need to tell it explicitly to unpack, it just knows to do it. And so we'll get, but it'll print the same thing. Here. Here we're printing the text variable, and here we're printing the text string. And we don't need to wrap this in a print statement because this is the last line of the cell, and we're in the Jupyter environment, it just prints the last part of the cell negatively. If I was in a script, I would need to do this. Okay. User input. Oh, and sorry, didn't have this conversation. Python, there's a big difference between Python 2.7 and Python 3. Not big, but there's a difference between Python 2.7 and Python 3. This workshop is, I'm using Python 3 because it's the new standard, and all the scientific computing libraries, it's the standard, and all the scientific computing libraries are end of lifing the 2.7 support around now in 2019. So going forward from about then in 2020, nobody's going to be supporting Python 2.7 anymore, so if you're starting new Python, you should be using Python 3. I know for the hires we don't use Python 3, we use Python 2.7. For everything we've been doing, all your code is going to run on Python 3. We don't do anything Python 2.7. Okay. So this is C formatting. And the reason I mention this is because in user input, in Python 3, input is only in string. Well, there is no automatic conversion of input. So if I want input from a user, I ask for input. I'm going to enter hello, and that's what is now stored in that string input variable. In Matlab, we still have both. In Matlab, we have both, you can have your x, which is your integer input, and your string input, which you tell it, hey, it's a string type. So Matlab means specifically tell the input function what type you're inputting. And if you don't, if you just do input and I try to put in a string, it yells at me. Yeah, Matlab, because by default it thinks the input is a string. Enter. And in my case, it also breaks my kernel. Okay, so I do 10, and I can do hello, and it'll keep that hello. And it stores that string input as a variable. So far, Matlab, any really different than Python?
No.
No. Right? So this, we're actually going to the part where it gets a little bit different. This is the part that always drives me nuts. Control logic. And we're going to look at Okay. So, in Python, if statements, we need a colon at the end of every condition. So colon, you do colon, and space. In Matlab, no colon, but you need a colon, you need a semicolon at the end of every line, and again, that's just for printing. You don't actually need it. This is just Matlab expression language, so technically I can get away without it. And then all this kind of stuff. And the biggest difference is in Python it's elif, Matlab it's elsif, and in Matlab you need to end your blocks. So you put an end when you're done with your logic statement. So what is this going to evaluate to? Either language, what's this going to evaluate to? 24, right? Is x greater than 3? Greater than 5? Yep, greater than 0, less than 0? No? So, yeah, so see if we're right 24, and so now, right, and we'll get a 24. So, a for loop, again, you have to steal from NumPy. So, how is this for loop going to evaluate? How is this for loop going to evaluate? Anybody know? So the biggest difference here is that Matlab will implicitly set up a range. If you do 2 colon, the start colon the end, you get an explicit range in Matlab. Whereas in Python, you have to explicitly say the range, 2 to 7, or whatever your starting off is. And the other big thing that's going to trip you up is in Python, it's inclusive. In Matlab, it's inclusive. So your end value is inclusive in your range. So you get 2, 4, 5, 6. So in 2, 6, you get 2, 3, 4, 5, 6. And in Python, range is exclusive. So if I did range 2, 6, I'd only get 2, 3, 4, 5. So you always need to do a +1 in Python if you're doing direct conversions. So you need to do the same. The other thing is in Matlab, we say for n equals, and to take on the successive values in our list. In Python, we do for the value in the list. So for n in range. And then the math, this is the other. This is the slice operation to subset into our array or subset into our list. In Matlab, it's in parentheses, and in Python, it's in braces. So, and I know this is going to be confusing for the Python folks because this is also a function. But yeah, so if I want like the first element of a list in Matlab, so basically, if I said n is equal to this, and I want n3, I do it this way in Matlab. And in Python, if I said n is equal to this range, and I want the third, I do it with braces. And the counting is different. Python counts from 0, Matlab counts from 1. So the reason I'm getting 4 here is 1, 2, 3, and the reason I'm getting 5 here is it's going to be is because it's 0, 1, 2, 3. So what does this actually do? We run the loop. Dx is and in Python the x is the same. It's the Fibonacci, and you're going to get the same numbers for both of them. And that 1, 1, 1 is just bad setup of the list. It's because we set up the ones to be 10 and we only actually have 6 elements. Okay, loops. Same story. In Matlab, we don't have colons, and we do an end statement to tell us when the loop ended, and we don't have accumulators. So we have to do n factorial times n to add. What this statement is saying is like n goes into the previous plus the current plus this new value, or times this new value. And in Python, we need a colon to end the control logic, and we said times equal n to get a new value. We can, so what means we can replace n is equal to n with times equal, and that's just the same thing as n factorial is equal to n factorial times n. By the way, this is also valid Python. We have accumulators here. And again, the semicolons are not mandatory; they're only there to suppress printing. And enter. And this is like very modern print. This is 3.6 onward print formatting where you can just throw the expression into the print string. And this. And then it'll print. And this was just like get the engineering notation. Because it depends on, because the engineering notation, it depends on the defaults. Like in Matlab, that's the default for large numbers. In Jupyter Lab, then remembers for this Python, it's not. So if I don't do that, what I get is this. Right, and that's the full number. Functions. So this is I think is the biggest difference. In Matlab, the return, where the function returns, is defined as what the function is equal to. So function f equals fact n means that the function returns f, the variable f. In Python, what we say is that we return f. So this return f down here in Python is the same as the Matlab function f. So this for Leslie here is the return, and in Python the return is what's the return. Again, product is just built into Matlab. In Python, we have to say explicitly. We, again, need an n+1 to be equivalent to the n, because in Matlab we're inclusive, in Python we're exclusive. What else? And here I'm using np.arange, but I could just use range. The thing is the range, the built-in Python range, only does integers, and np.arange lets me do floats too. But this works just as this is just a factor. And we call functions the same way. Function name, parentheses, and we get the same numbers. Again, Matlab, so it tells you that it's the answer. Python, it'll just dump the number. Dump in the number when you want to name it to print. Okay, so this is the part where, now this is the part where I'm like, my Matlab doesn't work yet. Not my Matlab, my Octave doesn't work. How many of you have done object-oriented programming in Matlab? Has anyone done object-oriented programming in Matlab?
that mean?
Okay. So this is an object in Matlab. Yeah.
Question. So when you're outputting a function in Python and Matlab, can Python output more than one?
Yeah. Yeah. Oh, that's a great example. Here. So what he means is in Matlab, what I can do is I can say function AB is equal to, I don't even know what. Just begin. Add 2. That is y. And I can say a equals a plus 2, b equals y plus 2. Plus 2. So I can set so I can do this. What did I say? Oh. Okay. So I can say add 2, 4, 5. What does that mean? Okay.
I think it's brackets. Brackets. Matlab.
Oh. That's it. Yeah. So in Matlab, you can return a list by saying function in brackets your return it types add 2, and in Python what that is this. Return a. So 4, 5. 4, 5. And it'll return 6 and 7. What did I lose here that it's like? Okay, so what did I miss here about the, yeah, so you can do this. So in Matlab you can have your 2, and in Python it's the same thing, your 2. And like in Python, I can also say A is equal to this, and then it's A0, A1. And then in Matlab, I can do A is equal to, and then A0, and A. Okay, maybe I messed up. Okay.
When? You have your parents.
Any other questions on this? So you can do your multiple choice work, your broadcast work.
So Monday for all meetings for 24.
Okay, so like I was asking, has anyone done object-oriented programming in Matlab? This is a relatively new feature to the language, so my guess is you all didn't learn it. Did you learn it? Objects?
Matlab.
In Matlab, you learn objects?
Yes,
No. Okay. Python, y'all didn't either. So we're good. We're on an equal basis of no one is polythene. So in Matlab, we name the class. In this case, we're doing a circle class. We do the properties, the radius, the functions, the positive. We define our methods as name the methods, what they return again, and we need to pass in our object when we do stuff to the methods. So that's what that defining an object looks like in Matlab, and again, you need to end everything. And in Python, you use a class. You say, like in Matlab, you have the class def. In Matlab, you have class def. In Python, we have class. Circle that inherits from a base Python object. We have the def in it, which is called the constructor. That makes our object. And constructor is the equivalent of, in Matlab, doing this, the function that has the same name as the class. Function within the class is called the constructor in Matlab, and in Python is the init function. So, and we raise exceptions in Python using raise. In Matlab, we just say error. Both are raising exceptions. Other methods in Matlab, you need to take in the object on what are called the methods. And in Python, it's the same thing, you take in self. So self in Python is Matlab, the self. What we're calling the self here, the object. So we say, we return it. Again, pi is just built into Matlab, so you can use pi generically, and it's just coded to be, in Matlab, pi is pi, the 3.14. In Python, it's not built into the language, so you grab it from a library. In this case, I'm grabbing it from the Python, from the NumPy library. And that's the thing with a lot of these mathematical constants. Like the NumPy library and the SciPy library, or any specialized library for that thing will have it. And in MATLAB, they won't. And Python libraries are the equivalent of MATLAB toolboxes. In MATLAB, you use toolboxes to get specialized stuff, right? Like the specialized signal processing tools or specialized visualization tools. And in Python, you import a Python library to do the same thing. And for a lot of MATLAB libraries, they're actually Python. For a lot of MATLAB toolboxes, they're Python library clones. Like the Python numeric programming language, scientific programming languages libraries, Matlab, Matlab, and SciPy are clones of Matlab. Like they start out originally as clones of Matlab, which is why they're so syntactically similar. And they try to keep a lot of functioning the same. Okay. So, if we call a function in Matlab, we have multiple ways to do it. We can call the function using, we create the object, creating the object, we create the object. We can call the function, the method, with the object as an argument, or using the dot notation, C dot the name of the method. We can, and all the methods is the same thing. We can call them using, passing the object with this argument, or using the dot notation. In Python, we use the dot notation directly. We can say C equals circle, we create the objects the same way, calling the constructor with the name of the object, and we do the dot notation to call the methods. I only have this working for Python because I said in Matlab it doesn't work. And then we plot. What's up? You had a question? I don't big things. We'll plot. And plotting looks basically the same. So we plot using the plot command. We pass in the x, the y, the color, we pass in color, marker, width, etc. It doesn't work on here, but the plotting in Matlab is, see, we're plotting the, again, we're just plotting the object radius. And again, width, face, cosine, sine are built into Matlab, and in Python we need to grab them from the NumPy library. The other big thing is, this is called showing the object-oriented way to do plotting, but there is a plot interface that more mimics the MATLAB style. Put up a plot with stuff on it.
He was in my desk.
If you want to know for your specific things, your specific project, like a cheat sheet, there is, so you can call both. From MATLAB, you can talk to Python, and from Python, you can talk to MATLAB, so you can write scripts that talk both ways. And if you want to know for your specific project, it'll usually be a NumPy to MATLAB, or MATLAB to NumPy conversion. And so there's a cheat sheet. So here's what it looks like in MATLAB, and here's what it looks like in NumPy. So it's usually one or the other. Use one or the other. So pretty much, what's I say? Pretty much anything you can find in one language, you can find in the other. Or pretty much anything you find in MATLAB, you can find in Python. I don't know if MATLAB has anything Python. Just MATLAB. Questions? So far. Yeah.
Yeah, we'll be getting those links.
Yeah, I can send Caesar the link to the GitHub because this is all on GitHub and it's all vended on GitHub.
GitHub?
Yeah.
That's where we get all the stuff.
Yeah. Yeah, it's a code hosting repository, so all of the code and stuff is out here, so you can just have it. Yeah, so I'll send Caesar the link. And all of the these links are inside that. Other questions? Things you want to do and you want to know, can I do it in which language? Yeah.
So are you going to, can we read like .nc and what's another one?
NetCDF?
Yeah, NCDF.
Guys, can we read NetCDF files in Python?
Yeah, they're going to try to guess it. No, it's not my question if they can do it in Python because I don't use Python.
Oh.
Is it similar in the way it is in MATLAB?
So the way you want to do it in Python is you use the X-ray library, and it basically looks at it up into a database structure that looks a lot. It functions the same as an HDF5 in MATLAB. Because in MATLAB you use an HDF5, it's something like an HDF5. Here, I'll show you because it's probably easy to show you.
I saw it.
So, yeah. Sorry, I like blew out my glass. Yep. Lancet_hires.nc. Yeah. Yep. .nc
Sean?
Washing machine. Let's have a better. No.
Okay.
I blew up my environment yesterday while making this, so I just need to make sure I don't. Oh, okay. So the kids have been working with this one project. They've been working with the NetCDF, the Lancet NetCDF file of Lancet data for 21 timestamps for the past couple of days.
Okay.
set kernel. So if it like so here I have a lambda file in my data. Oh, this is a Jupyter notebook, and the thing I like about it is that it has the autocomplete. So that's the thing, in the Jupyter environment, you can have the same autocomplete as you have in Matlab. So if I load in my data set, it says, so if they use the X-ray library to load it in, then it looks like this, and it has all the functionality in it. So then they can get out their channels. These are the data channels.
So that's equivalent to like a NC disk?
Yeah.
Okay.
Yeah, and so like if they want like the near channels, they just subset, and that gives them the near channels that they can work with, and it has the the values, and that gets up to me. But they don't even need that because they can do all the math. Yeah, someone asked how to do it with the PDF file. So they can just do that, and it'll do the it'll do all the yeah, and it has the last one for time baked in. Because I didn't graduate. Oh, nothing. The data set. Yes, this is the data array object, and the data array object is we're calling it a data set because we're opening the data set, but it's
You mean like
the
doing
data array object.
Like the
Yeah.
difference of which
Okay,
everyone! Hi, please. Thanks.
So when you make an array in Python and Matlab, when they read it, it's in the upper left corner, it starts. Does Python read it a different way?
Oh, I know what you mean.
It reads in the lower left corner, right? Starting lower left.
Basically, this one thing is you're doing a geo array, they're upside down in Python, and you need to yell at it to do it right side up. Or you use like what are called the you use Cartopy, which is a visualization library for maps in Python, and if you use Cartopy, it'll automatically do flipping for you for the visualization. Otherwise, what we do is you can set an argument into the visualization, the intro, saying origin equals lower, and it'll flip it for you. What's up?
I understand deviation like that.
It's fine. So do you want the time or the x and y? Okay, so that's the standard deviation for y'all for X-ray. Here's your time on the time dimension for y'all. So you can plot. It's fine. I like scatterplot is in one of your notebooks. Scatterplot, I think, is in the 17B notebook. So you can have that, and your x and y is here. Yeah.
One week and the next week is like
here's your figures.
This is in your notes. Well,
Come on, guys.
no, they're not. Sorry, they have the final point. You finish this.
Oh yeah, you're right. You made that. You made that.
Do you all have questions? Yeah.
This is like the map according to the mapping example.
To make the map?
Oh,
So in this case, I'm just using so like for this one, what happens is because I'm using because I'm using X-ray, it's geo-aware, so it'll just it'll do the projections automatically. It'll do the projections of leaf and foot. The thing is with Python is it depends which plotting library you use for the mapping. If you use Cartopy or if you use basemap. And Cartopy is what you should be using, and I'll show you I don't have a live example of that, so I'm going to just show you. This, yeah. So theirs tends to look like, so their copy plotting tends to look like this. So I don't think this works the same way the Matlab does, because it's very baked into the Matlab way of plotting. And so here we set up the projection. We make a plot, then we set up the projection, and then we just plot it using InShow, the way we would plot any matrix in Python. And, or in this case, I guess, just so, because that's the visualization. Like we would plot it, we would typically plot a matrix of whatever type of data we have. And we set the coastlines and stuff.
I mean,
If you need grid lines, you actually use BaseMap, which is the older library, but it's not really maintained. Or it's kind of trying to end up like itself.
Oh no.
Okay. Yeah?
In Matlab, when we set variables about files, instead it's set to structure data type. Is this possible in Python?
What type of data are you talking about?
When we read a file, when we set a variable equals to a file in our directory, it sets it up as a structure data type for the variable. Is that the same for Python?
If you just open the file,
When you set a variable equals to a.
So like if I set my variable equal to my netcdf, you say? Oh, I think I know what you mean. So you're saying you're saying that like in this case, if I did something like s, like data set is equal to
Something like that.
my netcdf files, or it's not going to natively use my netcdf. Or like if I do a CSV.
Yeah.
So, okay, this might not be supported. So if I do this in MATLAB, in a proper model in MATLAB, it'll give me a data structure? Or do I need to do open?
Yeah, we'll give you a data structure.
Okay, Octave won't support that, I guess. So I can't do it. No, in Python you're gonna have to use the library. So like that one is a CSV. So I would need to, Python isn't that smart, so in Python what I would have, but you can basically do it. Yeah, I'll show you what I mean. What you're going to do is you're going to import the pandas library for CSV. Import pandas as DB. And we're going to p.read CSV. And if I do that, it's going to print out the data frame, which I think is what you get. So it'll print out the data frame, and I think that's what you use to Matlab. Right, this is Python. In Python, you need the ds.read.csv, which is what was happening with the X-array, where we were reading in the X-array, and then that sorted into that variable is the data structure, and it holds that. So, like what was going on here, where we did the DS, and once we did it, it holds the data structure for that netcdf file. But yeah, in Python, because in Python this stuff isn't part of the core language, you have to say which library you're going to use to actually read a file. In MATLAB, it's all part of the core. Other questions? Any other questions? More questions? Do you all have questions going from Python to MATLAB? What? Is it the airphone? At the end of every control structure. So like at the end of every if block, once you're done with all of your else ifs, you put it there at the end of the for loop. If you're doing nesting in each nest, you have to do it. So in MATLAB, if I'm doing something like and for the record, Python is more complete than Matlab because Python is a general purpose language, so you can do anything in Python. Matlab, you're geared towards science and computing.
So it's easier to use it with like
No.
It's more.
All the scientific labs, like so here, so I'm gonna, okay, so if I have like if x greater than 10, and then I want underneath here, if y is less than 5, b is equal to 10. I need an n for that if, and then I need another n for that if. Yeah, and it's if statements, functions, loops, any what's called code block in Matlab needs an n. And in Python you use the indent to show things up. The convergence is being the same language. I feel like so this is any other questions? What's up? Loud? Oh. No, it's a good question. It's like, does someone build a tool that automatically converts from one to the other? I haven't seen it. I don't think there is. I think what most of it is like they have a ton of code in one or the other. They use the Matlab tools to talk to like, so you like call your Matlab from your Python from your Matlab. But like there was a good point there, like Matlab, because Matlab is a company, it's by MathWorks, and Python is an open source library, so and it's built by volunteers basically. Python is an open source language. It's mostly built by like volunteers. Matlab is a product by the MathWorks company, so some of the differences in like polish are due to that. Have you seen Matlab question plus? Yeah. Okay. More questions? Well, that's actually why we use Python for the high schools. So that like if you want to go home, download it and you go down. And because, like I said, Python is more for Matlab is for science and computing specifically. Python is much more, it's a general language, so you can do like everything from science and computing to both sides. Okay, other questions, more questions, specific tasks you're interested in? Yeah.
How are their plotting? I'm sorry if you went over this already. I just walked back in.
No, it's fine.
Yeah, like plotting and using data arrays and all that. Well, first, do you guys have like a workspace or like a command window or anything in Python?
In the Jupyter Lab, which is the one I'm using now. Here, so we have the cell tools and so you can get extensions to do a lot of those things. Or what the high schools have been using that's much more, looks like a Matlab clone, is Spider. So the Python Spider practice.
And that'll have like saved arrays and all that stuff.
To see, if you want to see them. Jupyter Lab has that too. I just haven't quite figured out yet how to pop up that variable to see that. So we have all that. And the question was, how do you do plotting?
Yeah, like if you have saved arrays and all that, if you want to call on it later on.
Okay, so
This doesn't seem like you can keep track of things very easily.
So one of the ways to do it, but is, so let's actually grab an array. So np dot random dot rand int. So if I do here -5 to 6, and I'm going to do 45 value. Right, so this is my A array. So if I want to plot it, what I can do is just do plot up intro A, and I'll plot the array.
Okay.
And I can do plot title.
Okay. So you have to do.
So it looks, so there's also an object-oriented way, which is the way I prefer to do it, but you can do like the Matlab, just plot dot, and it takes in all the same things. So I can also do CMAT. So it has like over like 20 different color Matlab. Like all the Matlab 1 plus 4. And then the next question was tracking variables. So like I said, there is a Jupyter variable extent window. The other thing is you can also do inline views. And that'll dump all the variables.
Oh, everything you've done, and you just type in who's, it'll.
Yeah, it'll dump everything in your work spec.
Okay.
I think Matlab actually has a good one.
Yeah, it has to.
Yeah, Matlab also has a good. So you can get who is in the scope. The other thing that I like is like the equivalent of the Matlab help is is a question mark, and that'll give you all your documentation. And you can do plot and 2 question marks, and that'll give you the source code. How stuff has been implemented. What questions?
Oh no, that's all I had in my mind.
Okay. Any other questions for y'all? Good. Matlab, Python, Matlab.
Thank you.
Okay.